Terraforming Uranus, one of the two ice giants in our solar system, would be a monumental task. Ice giants have a high concentration of ices like water, methane, and ammonia compared to gas giants. Gas giants are primarily composed of hydrogen and helium gas. With the advancement of science and technology, it may be possible to make Uranus habitable for humans. Welcome to AgiRex. In this video, we will delve into the science and technology that could make this once inconceivable idea a reality and explore the potential benefits and challenges of creating a habitable environment on this distant and enigmatic planet. Uranus is located much farther from the Sun than Mars or Venus, with temperatures reaching as low as -224 degrees centigrade, -371 degrees Fahrenheit, and has no solid surface. Uranus is primarily composed of hydrogen and helium gas, with traces of methane, water, and ammonia. The atmosphere is thick and contains swirling storms and a strong magnetic field. Uranus's core is believed to be composed of rock and metal, and there may be a layer of liquid diamond formed under the extreme pressure and temperature. Despite being classified as an ice giant, Uranus is not entirely made of ice, and also has rocky and metallic cores. To terraform Uranus, the first step would be to create a solid surface on which humans could live. This could be achieved by introducing a large artificial object into the planet's orbit, such as a massive space station or a giant solar reflector. The object could serve as a hub for human activity and provide the necessary energy for terraforming. The next step would be to create a thick atmosphere to protect against the harsh radiation and cold temperatures. This could be achieved by releasing gases such as methane and water vapor into the atmosphere, creating a greenhouse effect and warming the planet. Over time, the atmosphere will become thicker and more Earth-like, allowing for the growth of vegetation and the production of oxygen. Establishing a sustainable ecosystem is crucial for terraforming Uranus. This could be achieved by introducing genetically modified plants, animals, and microbes capable of surviving in the harsh conditions of the planet. They would help create a self-sustaining ecosystem. With the right genetic modifications, these organisms could also produce oxygen and remove carbon dioxide from the atmosphere. However, one of the major challenges of terraforming Uranus is its extreme distance from the Sun. The lack of solar radiation and energy makes it difficult to provide the necessary resources for terraforming and maintaining a habitable environment. One potential solution would be to use nuclear power, which would provide a reliable source of energy for the planet. Another option would be to redirect sunlight to Uranus using solar reflectors or other technologies. However, these solutions come with their own set of challenges and risks. Another potential challenge of terraforming Uranus is the presence of methane in its atmosphere. The blue color is not due to water, but rather due to the presence of methane gas in its atmosphere. Methane gas absorbs red light and reflects blue light, giving the planet its distinctive blue-green hue. The high concentrations of methane in Uranus's upper atmosphere also contribute to its cold temperatures and its overall appearance. To address this issue, scientists would need to find a way to remove or reduce the amount of methane in Uranus's atmosphere. Despite these challenges, the potential benefits of terraforming Uranus are enormous. The creation of a habitable environment on this planet would provide humans with new opportunities for exploration, resource extraction, and settlement. Additionally, the development of technologies and strategies for terraforming Uranus could have far-reaching implications for the future of space exploration and colonization. In conclusion, terraforming Uranus is an ambitious and challenging goal, but not an impossible one. With the right resources, technology, and planning, it may be possible to transform this ice giant into a habitable world. The potential benefits of this endeavor are significant and could pave the way for new frontiers in space exploration and colonization.